Hi everyone. Today my topic is conditional distributive function with interval condition. Before going to this topic, we need to discuss about point condition, and we can see that this is a distribution function which consists of a known event and unknown event. We can compare this formula with the normal conditional probability equation, which consists of a known event, an unknown event, or a condition. By looking at this formula, P of A by B, with this A is an event which is known to us, and this B is an unknown event, or we can say it as a condition. With this condition, we need to know the probability of this event. So we can write this as P of A intersection B, A intersection B. We can say that these both events are simultaneously happening. Then now we need to look at this formula. In this we are having a joint density function of x and y variables, random variables, and by looking over here, we can say that when these x and y random variables are independent, we can write this joint density function as f of x and f of y of y. If these x and y random variables are not independent random variables, we can put an intersection between these two random the density functions. Then this part of this equation is exactly equal to this part. So we can say that by using this function, we need to keep a condition like this is an unknown event to us. At this event, we need to keep in condition like the random variable consists of a single point. Then we call it as a point function. Now as it is a single point, we can call this as a constant. So in this equation, the whole y is a constant, and by ranging these x random variable from minus infinite to plus x, we can get the value of density function of x. So this is about point condition. Now here we can see that f of x comma y of x comma y means intersection between known and unknown events. So the statements tells about these two lines. So here when we look at this interval condition, the difference is that we can see that the unknown event or a condition is in a continuous range, like it is in between a finite range which consists of the lower range as y1 to upper y2. Now here by comparing these two equations, we can say that here in this equation the y is a constant, but in this equation we are also ranging this y from y1 to y2, and we keep this unknown event as simply fy of y as y is an constant or a point. Here we are using a range, we are integrating it from y1 to y2. So this is about the density function, the distribution function. If we differentiate this distribution function with respect to x, then we will get the density function of this interval condition. Thank you.